Section 13.4 is the last we will cover in this chapter, and all we are doing, we don't need a new, we need to be able to go in the reverse way, and this is called just the inverse trig functions. Inverse trig functions. And so the way this works is like any inverse function, you switch the domain and range. So this time it means given the ratio of two side lengths, given the ratio of two side lengths of two side lengths of a right triangle, given the ratio of two sides, what is the angle? It's like Jeopardy. It's like going back the other way. What is the angle? Now, there's some definitions here that you won't need to memorize, but you need to be able to refer to it and know what it means. The symbol for inverse is like this. You're going to see a little -1 symbol of theta. So -1 means it is not, that is not an exponent. It means simply take the inverse. That's all it means, and you'll see it on your calculator above the sign button is, let me zoom in here, above the sign button there's a symbol that shows you that sign, and there's a little tiny -1, and all it means is go the reverse way. That's all. So so sine inverse and tangent inverse are only defined in order for it to be a function, because you'll see when we do examples there would be more than one answer possible. We can only have one answer for to be a function. Is only defined in quadrant 1 and quadrant 4. That is not something that you'll memorize in this class, I would tell you, or you'll have it on a little cheat sheet. And then the cosine is only defined, and you'll understand better why in the next unit, is only defined in quadrant 1 and 2. So right now, don't worry about why. That's just the way it is. You'd be given those things. Okay, so now we're gonna practice doing some examples. So here's something like test objective. So I'll put a little bullet here. Evaluate in, we're gonna just do radians. Evaluate in radians. So the first example is find the inverse sine of √2/2. That's the question. So what I would do, there's no work to show here. I would look on my unit circle and I would go to √2/2, and I know the answer is only in quadrant 1 and 4 because I was given that. So if I look at my unit circle, √2/2 for the sine is here, and there's only one answer actually, and it's pi/4 in quadrant 1. The other place where the sine is √2/2 is over here, and that's why we need to limit where it's defined. The inverse sine is only defined in these two, so we'll always use this quadrant 1 answer for so it's going to be pi/4, and that is, and you would write pi/4. And that's the work that you would show. Number 2, let's try the inverse cosine of 1/2. Inverse cosine of 1/2. Well, inverse cosine is only, I only need to look in quadrant 1 and 2. There's only one place where the ratio of side lengths is 1/2. So where is that? Cosine, that's the x coordinates 1/2. It's right here. So that's at pi/3. Pi/3. We'll do two more examples. Now it can get a little bit, here's a little twist here. Inverse tangent of -1. Okay, so where is the tangent -1 is what we're asking. Where is the tangent -1? So we need to look in quadrant 1 and 4. well, the tangent is negative only down here. So where is it -1? That would be right here. Because remember, it's the same as up here, same as the reference angle. So that would be, now, we won't say 7 pi over 4, we'll say negative pi over 4, because the angle 7 pi over 4 is where you rotate all the way around this way, and we can't do that if we want quadrant 4 only. So you would just go from here down. So you would answer negative pi over 4. It's a coterminal angle anyway, and we can only move in this direction or this direction. So it's going to be negative pi over 4 for your answer. Negative pi over 4. We'll do another example that's similar to that. Inverse sine of -1/2. Inverse sine of -1/2. Again, this is only defined, so where is the sign -1/2? Either this way or this way. So we need to go this direction. So we're asking, where's the y coordinate -1/2? It's right here, so it's negative pi over 6. You're not going to say 11 pi over 6 because that would involve going into quadrants that we can't go into. So you would just say negative pi over 6. The unit circle says 11 pi over 6, but we're going to say negative pi over 6. And again, until we get to graphing these in the next unit, it will make more sense why. That's all there is to that. Now we're going to do, we're going to actually solve an equation using the inverse. So let's say I have solve the equation for theta, and we're going to do all of these in degrees. So we'll be in degree mode on our calculator, and we'll do a few examples. So let's say we have the cosine of theta equals 0.4. Okay, this is considered a trig equation that I want to solve. So what you do is, what you would show in your work is you're going to take, I want to know what theta is, so I'm just going to take the inverse cosine of 0.4 because I need to go the reverse direction, and that will give me my answer for theta. That's what theta equals. So I'm going to actually write it this way. Theta equals the inverse cosine of 0.4. And so on your calculator, you would put 0.4. Be sure the default is degree mode on your calculator. If you put in 0.4 and you take the inverse cosine, you have to hit second cosine. It's right above it. That will give you an answer of 66.4 degrees. Okay, however, in this question, it says that it wants your answer between 270 degrees and 360 degrees. So there are actually two places where we would get 66.4 degrees, where the cosine is 0.4. It's here or here. There are two places where the x coordinate would be 0.4. Here or here. The calculator can only give us this answer because it's defined in quadrant 1 or 2. So the calculator said the answer is 66.4. There's nothing wrong with that, but we need our answer between 270 and 360. So what we need to do is find the angle that goes from here to here, and that will be our answer. So here's where you use geometry and angles. What is this angle from here to here? If you see the symmetry and you know that's 66.4, how do I find that the other angle that's in the range that I want? Exactly. You do 360 minus 66.4, and that gives you your final answer of 293.6 degrees. That's how you do these problems. And we're going to do some more examples on Monday.